Look up from any Australian beach, farm, city street or outback road, and you are looking through a stack of invisible layers that control far more than the colour of the sky. The atmosphere is usually described in 5 main layers, starting at the ground with the troposphere, then the stratosphere, mesosphere, thermosphere and exosphere. Air pressure drops as you go higher, so the air becomes thinner, colder or warmer in different layers and much less dense. That change with height is one reason clouds, winds, aircraft, meteors, auroras and satellites all belong to different parts of the sky. For everyday weather, the layer that matters most is the troposphere. This is the lowest layer, and it holds most of the atmosphere's mass and almost all of the weather we experience. Clouds grow here, rain falls here, thunderstorms build here, and tropical cyclones are steered by winds through the lower and middle troposphere. When the sun heats the land or ocean, warm air rises, cooler air sinks, and that overturning helps create showers, storms, and sea breezes. The top of the troposphere is called the tropopause. It is generally higher over warm tropical Australia, such as around Darwin, and lower over cooler southern areas, such as around Hobart. That matters because a deeper troposphere can allow taller storm clouds, especially in the tropics where heat and moisture are abundant. Forecasters do not just guess what is happening up there. Weather balloons carry radio sondes upward through the troposphere and beyond, measuring temperature, humidity, pressure, and wind. That vertical profile helps the Bureau of Meteorology understand cold fronts, storm strength, wind shear, and the steering winds that can change a cyclone's track. Near the top of the troposphere, fast ribbons of air called jet streams can also shape southern Australian weather. When the jet stream strengthens or dips north, it can help guide cold fronts, cloud bands, and bursts of colder air into Western Australia, South Australia, Victoria, and Tasmania. Above the troposphere is the stratosphere. It is drier and more stable, and it contains the ozone layer, which absorbs much of the sun's harmful ultraviolet radiation before it reaches the surface. That protection matters for skin health, crops, marine life, and places like the Great Barrier Reef. Over Antarctica, the ozone hole is a seasonal thinning of ozone in the southern hemisphere stratosphere. It is linked with very cold stratospheric conditions and the Antarctic polar vortex, a strong ring of winds around Antarctica. This vortex does not control Australian weather every day, but it does influence stratospheric temperature and ozone patterns across the southern hemisphere. Higher still is the mesosphere, where many meteors burn up as they enter Earth's atmosphere. Above that, the thermosphere is where aurora australis can appear when particles from the sun interact with atoms high above Earth. During strong geomagnetic activity, the southern lights may be seen from Tasmania and parts of southern mainland Australia. The exosphere is the outer edge, where the atmosphere gradually fades into space. Satellite navigation signals also pass through upper atmospheric regions, including the ionosphere, and can be slightly altered on the way down. So each layer has a job. The troposphere gives us clouds, rain, storms, and cyclones. The stratosphere helps shield us from ultraviolet radiation. The mesosphere burns up many meteors. The thermosphere helps create auroras. The exosphere marks the transition towards space. For severe weather in Australia, start by watching the lower atmosphere, but remember the whole stack matters. From a thunderstorm over the outback to an aurora over Tasmania, the atmosphere is not just air above us. It is a layered system that protects, connects, and constantly reshapes life below.